Okay, let's start with a wild thought. What if our most basic, fundamental understanding of energy is just plain wrong? We're about to go on a journey, and it's a big one. We're going to connect something as simple as flipping a light switch all the way back to the very first moments of time. So, yeah, let's dive right in. So, what is that connection? What's the thread that ties the Big Bang, this massive universe-creating event, to the humble light bulb sitting in your room? It's a great question, right? But the answer, as you're about to find out, is, well, it's a whole lot more mysterious and honestly, way more debated than you'd ever imagine. Okay, so before we can really get into that mystery, we've got to start with what we all think we know. You know, the familiar stuff. Let's just quickly walk through that story of electricity we all got taught in school, the official textbook version of how our entire modern world gets its power. And that story, like pretty much every story in physics, begins with the atom, this tiny, invisible little building block of matter. You can think of it as the source code for our entire physical reality. It's the starting point for literally everything: a rock, a star, you, me, and most importantly for us, the energy that makes everything go. The standard story is, it's pretty straightforward. You've got these tiny little particles called electrons, and they're just zipping around a nucleus. And when we apply a little push, we can get those electrons to flow through something like a copper wire. That organized parade of electrons, that's what we call electricity. It's the magic that gives us light and heat and motion. And look, this is the really cool part of the story, right? It's the story of human achievement. By figuring out how to control this flow of particles, we went from this invisible atomic world to literally creating our own lightning bolts with things like Tesla coils. It's an amazing story of us mastering a force of nature. But, and this is a big but, is that really the whole story? Yeah, because right when everything seems nice and settled, you find a crack. A big one. Right in the foundation. It turns out this simple little particle story, it's been under fire for more than 100 years. And that brings us to what you could call the electron paradox. Okay, so according to the textbooks, the electron is a real thing. It's a solid, subatomic particle, like a tiny, tiny little ball carrying a negative charge. It's the main character, the hero of our electrical story. But what's fascinating is that some of the greatest minds in the history of science looked at this so-called hero and basically saw a ghost. Take Nikola Tesla. He actually questioned whether it even existed as a particle at all. He basically said, look, for the mass to work out, this electron thing would have to be a perfect, hollow sphere, like a tiny bubble. But then he pointed out the obvious problem. A bubble that perfect would be unbelievably fragile. The slightest little nudge, and poof, it's gone. For Tesla, this particle just didn't hold up in the real world. It didn't make any physical sense. And it wasn't just Tesla being, well, Tesla. You had Charles Proteus Steinmetz. This guy was an absolute giant in electrical engineering. He actually perfected a lot of Tesla's inventions. Over 100 years ago, he called the whole idea of the electron prehistoric. He argued that forcing ourselves to think of electricity as these little particles actually makes things harder to understand. It messes up the beautiful, elegant symmetry of the electric fields. So if it's not particles, then what in the world is it? Well, this question leads us down a rabbit hole to a completely different way of looking at the universe. It's a reality that isn't built on tiny, separate little bits of stuff, but on these vast, interconnected, flowing fields of energy. So this really sets up two completely different visions of reality. On one side, you have the standard model, which says electricity is made of things, these electron particles, physically moving through a wire. But on the other side, you have field theory, which says, nope, no things are moving at all. Instead, electricity is just a disturbance, like a ripple or a pressure wave in an underlying field, a combination of two forces, dielectricity and magnetism. Yeah, in this way of looking at it, electricity isn't a thing, it's a phenomenon. It's an event. It's simply what happens when these two fundamental fields, the dielectric and the magnetic, interact with each other. The key idea here is that energy is being transferred, not that particles are being transported. Big difference. And this is where things get really, really mind-bending. Because if there are no separate electron particles, if everything is just a different ripple in a single underlying field, well, that means the separation we see between things isn't really real. It's an illusion. Fundamentally, everything is connected. Everything is one. Now,
This deep, fundamental uncertainty about something as basic as an electron, it's not a one-off thing. It's not an isolated case. In fact, if we zoom way out, from the tiniest particles to the biggest possible picture, the entire cosmos, we find the exact same kind of debate raging about the very origin of the universe.
And you're probably sitting there thinking, wait, how can the experts disagree on something so fundamental? It seems crazy, right? But is this kind of disagreement really that rare in science? The answer is a huge no. This is how science actually works. It's messy. Think about it. When we ask the biggest question imaginable, what was there before the Big Bang, science doesn't hand us one tidy, simple answer. Not at all. Instead, it's like we get handed a menu with a bunch of fascinating, competing, and sometimes totally contradictory options. You've got your standard Big Bang theory, the one where everything explodes out of an infinitely small point. Then there's the Big Bounce idea, which says our universe is just the latest in an endless cycle of expanding and collapsing universes. And then there's the really wild stuff, like the brain collision theory, which imagines our universe being born from the collision of two other parallel universes, like giant cosmic sheets smacking into each other. And I get it, seeing all these disagreements can make science look messy and uncertain. But that's not a flaw. It's its greatest feature. It's the engine of progress. This is what real discovery looks like. It's a relentless, fearless mission to figure out how reality works, no matter how weird the answer ends up being. So, after all that, where do we stand? We've gone from the tiny, uncertain world inside an atom all the way out to the mysterious birth of time itself. And this whole journey points to a really powerful conclusion about how we learn things, about our search for knowledge. And here's the most important takeaway. The story of science is never ever finished. It's not a closed book. That nice, neat line we like to draw from an atom to a lightning bolt, that's still just a rough sketch. The book has empty pages, and some of the pages we thought were finished are being furiously debated and rewritten as we speak. And please, don't think this is some newfangled debate. To put it in perspective, as of 2026, it will have been 109 years since someone like Charles Steinmetz was openly calling the concept of the electron prehistoric. 109 years. These big fundamental questions have been hanging around for a long, long time. So, what's the bottom line here? It's that science isn't a book of facts. It's a process. It's about questioning. It means that even the most foundational bedrock concepts can and should be challenged, because the greatest discoveries we've ever made came from asking the biggest, scariest questions. Our understanding of everything is always evolving. It's a permanent work in progress, and that's a good thing. And that leaves us with one last big question to chew on. The whole debate about the electron proves that even what we think is solid ground can shift beneath our feet. So it makes you wonder, what other facts that we take for granted are just waiting for the right person to ask the right question? And more importantly, what are you absolutely certain about today that might turn out to be completely wrong tomorrow?